Hello everyone, in this video we are going to solve a CSES problem called trailing zeros. So in this problem, you are given an integer n, and the task is to calculate the number of trailing zeros in the factorial of n. To solve this problem, we first observe that all the trailing zeros are contributed by factors of tens, right? So if we divide n's factorial by a lot of tens until you cannot do so, the number of powers of 10 that you can factor from n factorial is the answer. So in order to factor out tens from n factorial, we can also focus on, so by representing 10 as 2 times 5, we know that n factorial can become some other numbers, and it is 2 times 5 times n. So now we try to factor out all these the prime numbers that contribute to 10, which is 2 and 5s. And if we represent n by a sequence of integers n, we know that for every 2 numbers is a number, of course, and we can factor out a 2 from there. And for every 5 number in the sequence, we can factor out 5, right? So we can have 5, 10, 15, 20, 25, and so on. So for every 5 numbers, we can factor out a 5. So we get 5 here, 5 here, 5 here, 5 here, 5 here. And we also observe that for 25, for example, it is 5 times 5, so that you can actually have 2 5s from there. So if you just try to observe this pattern and try to figure out how many 5s do we have, we can basically say, how many 5s can we factor out from all the n numbers, right? So this gives us n over 5, this many number of 5s. And then for every 25, every 25th numbers, we will have an additional 5 for us to figure out. But this is n over 25, and you can imagine that let's say if we encounter some multiple of 5 cubed, right? So that's 125. We will have 3 5s from there. So that means for every 125 number in this sequence from 1 to n, we will be able to factor out an additional 5 from them. This gives us a good pattern for counting how many 5s do we have at the end in the factorial of n. Right? So another observation is that the number of 2s that can be factored out from the factorial of n should be at least the number of 5s that we can factor out. So the bottleneck comes from counting number of 5s. Now let's try to code this idea up. So first we create a new file, and we read the input. And then how do we count this? We can basically start from the value. Let's see, we're gonna count how many 5s are there, right? So let's see, k starting from 5, and we have a total of trailing zeros, 0, and while k is still not exceeding n, we can try to say, let's count the number of occurrences for every multiple of k, right? So it's n divided by k, and k multiplied by 5. And then at the end, we get the number of total. So let's try this. If we have 20, we get a 4. Okay, let's try to submit it. We get accepted.